Okay, back to notes. Now, these next ones, these next angles and values we're going to be finding will not produce angles that are on our unit circle that are 45, 45, 90 reference triangles, or 30, 60, 90 reference triangles. So what we're going to have to do is just sketch the reference triangle and use the Pythagorean theorem to simplify these here. And so let's start with this one here. Cosine sine inverse is equal to cosine sine inverse of 3/5. So the first thing I have to remember is what is my domain of my sine inverse, and that's between -1 and 1. And the range of my sine inverse is between -π/2 and π/2. Okay, so we know sine inverse is positive up here and sine inverse is negative down here in quadrant 4. And since we could say that 3/5 is greater than 0, that we are looking for sine inverse in quadrant 1. So when we draw a reference triangle, that's where we're going to draw that triangle. So we have sine of 3/5, and that's opposite over hypotenuse. So opposite would be our vertical, and our hypotenuse would be 5. Okay, and so this is going to be angle theta. I don't know what, without using my calculator, I do not know what that angle measure is, but that's okay. That's why we're drawing the reference triangle. Now we can use the Pythagorean theorem, but hopefully by now you know that this is a 3, 4, 5 right triangle. So things we know about this triangle, the sine of theta is equal to 3/5, and the cosine of theta is equal to 4/5. We could also do the tangent and all of the other values. But since this problem is only built out of sine and cosine and sine inverse, we'll stick to those two values. So I'm just going to rewrite it here, cosine sine inverse of 3/5. And I'm going to work on this value first. Now again, I don't know what the measure of that angle is, but I did name the angle theta. So we're just going to do, okay, so the cosine of theta. And the cosine of theta we already found was 4/5. And so let's see, let me grab my colors here. So first I worked on that, and I drew that reference triangle, and I named the angle that we were talking about theta. And then I went and looked at my reference triangle that I built, and I found the cosine of theta, which was 4/5. Again, I believe you could plug this into Desmos, and so let's go do that. All right, so we're going to do cosine sine inverse of 3/5, and you'll see that it's 0.8, and 0.8 is equivalent to 80% or 4/5, and so that's true. So our work is true. All right, so let's take a look at this next one. Oh my goodness. So here we have cotangent inverse of x over 2. So we have some unknown values here. Okay, but let's talk about our domain of our cotangent, which is unrestricted. So we can plug this value in, even though we don't know if x is positive or negative. We don't know what x is. But let's remember that our range for our cotangent function, inverse function, is between 0 and pi. Now here's the thing, this is my adjacent over my opposite. So I know I'm in quadrant between 0 and pi. Okay, and so I know that my opposite is 2, but I don't know what my adjacent is. So I'm just going to call this x positive and call this x and it's negative because I don't know. And so I'm going to draw both of those reference triangles there, and I'm going to name that one theta. And I'm going to name this one theta because they are the same size. One is just on the left side of the coordinate plane and one is on the right. Okay, so here's the thing. If I need sine, I need sine. The thing is, sine is opposite over hypotenuse, and so I'm going to have to find the hypotenuse of one of these right triangles. They'll have the same hypotenuse. So I'll just go ahead and work off of this one. Here's what I know. X squared plus 2 squared equals the hypotenuse squared. We'll take the square root of both of those, and we get the square root of x squared plus 4 is equal to the hypotenuse. I'm going to get a little bit skinnier pen here. All right, so here's what we know. This hypotenuse has some value of a square root of x squared over plus 4. Sorry, the square root of x squared plus 4. And so here's what I know about that. Because I have to find the sign of that, that would be the opposite value, which is 2 over the square root of x squared plus 4. So now let's evaluate that. I'm going to go back to my fatter pen here. So we have sine of cotangent inverse of x over 2. And again, we couldn't find out what that angle value is, so we just named it angle theta. So we're going to, okay, all right, so that's the sine of theta. All right, and all I did was I replaced the cotangent inverse with the name of its angle. And then I found the sine of that angle, which was this 2 over the square root of x squared plus 4. However, just note that that has a radical in the denominator, and I'm not really into that. And so let's rationalize the denominator so that we get the radical out of the denominator. And we'll get our final answer here at 2 square roots of x squared plus 4 over x squared plus 4. And then so we just evaluated the sine of theta, which was our opposite, over hypotenuse. Again, you can plug that into Desmos and actually see that that's true. So I think I already started to do that here. I believe I did. Let's see. Okay, so that was what it, let me turn this one off here. So there's the square root of 2, number 8 graph is the answer. And then if I do number 9 graph and I turn on sine cotangent inverse of x over 2, watch what happens. Notice it changed color. Now it's purple. They are the same graph. And so again, I'm just trying to reinforce that you can use Desmos to check your work to verify that you're getting things correct. All right.